What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. And what we're going to be doing today is identifying quadratic functions and finding their vertex. Let's jump right into it. When we talk about the quadratic function, we want to be able to identify it both algebraically when written as an equation and also graphically. When we look at a quadratic function algebraically, it should be in this form: y equals ax squared plus bx plus c. For this, it's very important that the a value does not equal 0. Because what happens is if the a value equals 0, 0 times x squared is 0, and the x squared piece just doesn't exist. In this equation, a, b, and c represents any constant you want, whether it's positive or negative, and we just need to really make sure that we see this x squared piece. When you graph one of these quadratic functions, what you get is a U-shaped curve called a parabola. There's two ways this could look. For a quadratic function, the parabola could open up or it could open down. Sometimes what I'll say is this opens up like a cup and this opens down like a frown. Which of these following equations could represent a quadratic function? Well, in this case here, we have 4 different types of functions, and we need to know which one's a quadratic. The first one is not a quadratic function. That's an exponential function. You can always tell something is an exponential function when the exponent is a variable. In this case, that exponent of x makes it an exponential function. Choice B is a quadratic function. This is one of the form ax squared plus bx plus c. Just in this case, there's no bx term and there's no constant term. Choice C looks like it could be a quadratic, but there's a 0 here, and 0 times x squared would just be 0, which when simplified would just give us y equals negative 2x minus 7. You might recognize this now as a linear function in y equals mx plus b form. Choice D looks like it could be a quadratic function, but this is actually a cubic function because the highest power here is a 3. This would be something of the form ax cubed plus bx squared plus cx plus d, and obviously it's missing that bx squared term, which is fine. Either way, because the highest power is 3 here, it is not a quadratic function, but a cubic function. Let's talk about some key features of a parabola. The first key feature of a parabola is the axis of symmetry. The axis of symmetry is a vertical line, meaning that it goes up and down, and it's going to divide that parabola into 2 matching halves. Essentially, you should be able to take a parabola and fold it on top of each other because there's 2 matching halves. There's a line that you can slice right down the middle that could cut this in half. The formula for the axis of symmetry is just x equals negative b over 2a. The x equals part will always stay there. You're only plugging in for b and a, and you'll get some equation like x equals 2 or x equals 3. And remember, x equals a number equations are just vertical lines at that x value. The vertex is either the highest point or the lowest point on the parabola, and the vertex is always on the axis of symmetry. If your parabola opens up like a cup, then you will have a lowest point vertex. You won't have a maximum value. Where if your parabola opens upside down, you'll have a maximum value. I've created this chart here to give you some information about the vertex. Remember that the vertex is either the highest point or the lowest point on your parabola, but it can never be both. Well, if you look at your equation, the a value tells you quite a bit about your parabola. If your a value is positive, that means your parabola opens up like a cup, and if it opens upwards, then you're going to have a minimum value for the vertex. If the a value in your equation is negative, that means your parabola opens down, and if your parabola opens upside down like a frown, in that case you'll have a maximum value. I like to think of negative a values in a parabola as opening down like a frown on a clown. Think of this picture here. Doesn't this frown on the clown look like a parabola that could open downward? I sure think so. In this example, we're going to answer a lot of questions about the key features of a parabola. Notice we have the graph of the parabola, and we should be able to answer a lot of information about it. The first question says, does the parabola open up or down? Well, does this look like a cup or does it look like a frown? In this case, to me, this looks like a frown, which means it opens upside down. Well, when it opens upside down, what does it say about the a value from the equation? Well, when it opens down, the a value from the quadratic equation will always be a negative a value. Is the vertex here a maximum or a minimum? Meaning, does this parabola have either a highest point or a lowest point? Well, when I look at this parabola, it goes down forever, so it won't have a minimum value because it just keeps going down forever. However, it does have a maximum value, so here we could say the vertex is a maximum. Anytime a parabola opens down, it has a maximum value, and anytime a parabola opens up, it has a minimum value. What are the coordinates of the vertex? Well, here we want to find the highest point, which is right here. This is the vertex, and the coordinate of that point is 2, 4, where 2 is the x value and 4 is the y value. What is the equation of the axis of symmetry? Remember, the axis of symmetry is a vertical line that cuts this parabola in half, and it's always x equals some number. Here, the equation of the axis of symmetry is x equals 2. That's the vertical line that cuts this parabola in half. Notice, if I was to move this equation, none of these other spots would create two matching halves. The equation has to be x equals 2 in order to create two matching halves. The other thing that we should notice is the x value from the axis of symmetry equation is the same x value from the vertex. This will always be the same. Let's see if you could answer one of these questions about the key features of a parabola on your own. Part A says, does this parabola open up or down? What would this indicate about the a value of the quadratic function? Here, this parabola opens up, which means the a value would be positive. Is the vertex for this parabola a maximum or a minimum? Looking here, we can see that the vertex has to be a minimum value. When parabola opens up, there will never be a maximum value. This parabola goes up forever, so we won't have a maximum. Instead, we have a minimum value. What are the coordinates of the vertex? In this case, the vertex is that lowest value, and the coordinates of the vertex are 3, -8. What is the equation of the axis of symmetry? Recall, the axis of symmetry is an equation x equals some number, and it should cut the parabola in half. The equation here is x equals 3, and remember that the x value from your axis of symmetry matches the x value from your vertex. We already learned how to find key features of a parabola when we're given the graph, but what if we're given an equation? Could we do these same things? In this question, we want to know what is the vertex of this quadratic function, and if we graphed it, would the parabola open up like a cup or down like a frown? First thing we want to do is identify the a, b, and c values. A is the coefficient of x squared, which in this case is 1. There's an imaginary 1, which isn't exactly shown here, that is the a value. The b value here is the coefficient of x, which is 2, and our c value is -3. Once I know that my a value is a positive number, that means this parabola must open up. If the a value was negative, the parabola would open down. So I can eliminate choices A and B. Next step is I want to find the vertex. In order to find the vertex, I first need to find the axis of symmetry, which has this formula here. Simply plug in B, which is 2, and A, which is 1. Plugging in and simplifying, I get an axis of symmetry that is x equals -1. That is a vertical line that would cut this parabola in half. Once I know what the x value is of the axis of symmetry, that's the same x value of the vertex. To find the y value of the vertex, simply take this x value and plug it into the equation to find the y value. Plugging in -1 and simplifying, I would get a y value of -4. That means my vertex is the coordinate -1, -4, which sits on a parabola that would open up like a cup. See if you could find the vertex of the following function, then determine if the parabola opens up or down. In order to do this, the first thing I want to do is identify a, b, and c. A is the coefficient of x squared, which in this case is -1. Once we know what the a value is, we know if this parabola opens up or down. Anytime the a value is negative, the parabola opens down, so I can eliminate choices C and choices D. Let's find out the b and the c value. The b value here is the coefficient of x, which is 4, and the c value is the constant, -3. To find the vertex, we first have to find the axis of symmetry, which uses the formula x equals -b over 2a. We simply need to plug in b and a and simplify. Well, the b value here is 4, and the a value is -1. Simplifying, we'll get an axis of symmetry of x equals 2, which means if we were to graph this, at the value of 2, there would be a vertical line that cuts this parabola in half, and there it is, x equals 2. Now, in order to find the y value of the vertex, we just have to plug in the coordinate 2 for x into the original equation. Plugging in 2, we would get this. Simplifying, we'd finally get a y value of 1, meaning our vertex is the coordinate 2, 1, and we already decided that this parabola is going to open down. The correct answer here is choice A. See if you can find the maximum height of a ball thrown before it hits the ground, modeled by this function h of t. When we want to find the maximum height of a football, we should understand that because this function here has a negative a value, the football is going to travel like this, like a parabola that's upside down, and there's going to be some maximum height here. That maximum height is just going to be the y value of the vertex. When they ask for the maximum height, they're talking about the highest point on a parabola that is featured upside down. In order to find the vertex, let's rewrite our function and identify a, b, and c. A is the coefficient of t squared, which is -16. B is the coefficient of t, which is 48. And c is the constant by itself, 64. Bring up our formula for the axis of symmetry and plug in b and a. When we simplify, we can see that we have an x value of 1.5 for the vertex, which is also the same value used for the axis of symmetry, x equals 1.5. What this means in the context of the problem is that our axis of symmetry, or our highest height, will occur after 1.5 seconds. Now I want to know, well, how high will this football be after 1.5 seconds? So just plug that into our function. When we plug in 1.5 and simplify, we get a maximum height of 100, giving us a vertex of 1.5, 100. Well, what does this mean? This means that after 1.5 seconds, the football reaches a maximum height of 100 feet. Of course, if we wanted to, we could have graphed this function, and we could have seen that when we throw the football, indeed it reaches a maximum height of 100 feet after 1.5 seconds, just like the equation showed us. Well, that's it for me today. I hope in this video you learned how to identify a quadratic function, both when given an equation and when given a graph, and I hope you learned about the key features of a quadratic function. I hope you learned how to find the vertex, not only graphically, but also algebraically. Until next time.